Bismillahirrahmanirrahim. Okay guys, now we are discussing further on the tutorial. Previously we focused on bug. Now we going to take a look on boost. So question number 8 and question number 10 is regarding boost converter. So we shall put aside the bug boost question number 9 for further discussion. So we discuss 8 and 10 first. So what we have to do is that we transfer all the mathematical term into circuit. So we have source here of, so this is the circuit of boost converter. We have inductor and in diode, and the switch is between the source and the load. So we have a given here output of 12 volt and the output current of 1.5 ampere. So we put in into the circuit. And we have the source of 5 volt to 8 volt variable source voltage. Means that we are able to adjust, or the incoming is expected to vary or fluctuate between 5 to 8 volt. Means that if you have your battery, so your battery maybe will full charge at 8 volt, but maybe it will decrease down to 5 volt at certain times. So at any cost or any level of battery level, you should maintain the output of your boost converter at 12 volt. So that's the assumption. So the frequency of switching set assumed to be at 500 or set to be at 500 kilohertz. So what you need to do is that we have to find out the value of our inductor L, C and the other parameters with this assumption, which is we assume that the IL, the variation of inductor current, is to be less than 40% of average inductor current. So we put in mathematical term of delta IL less than 40% of IL. Then you should find the IL max and IL min, and also C, the value of capacitor for the circuit, such that the C will maintain our ripple less than 1.5%. So delta V naught, delta V out divided by V is equal to 1.5%, equal or less than 1.5%. So we need to find L, C, and before that we have to know what is our duty cycle and also our resistor value of our load. Okay, this duty cycle and resistor value has to be calculated for two scenarios. One is within a lowest voltage input, another scenario is at highest voltage input. So the voltage is not going to be at this identical value, but it will vary between 5 to 8. But we just find the range between the least or the minimum duty cycle up to the maximum duty cycle of our circuit. Okay, before we proceed, we go back to the what so-called the formula that the summary of formula that we have on buck boost and buck boost converter. So this is the basic parameter that we should know upfront in terms of our circuit parameters before we proceed with other calculations. So in terms of output voltage, so it varies depend on the duty cycle, and this is for boost, for buck boost, and this is your average current. This is your minimum required inductor value to have your circuit operating under CCM. Means that the current will flow or will fly above 0 CCM, continuous current mode. So it will not being dropped from positive 0 and then like this. Okay, in terms of their expression here, T is equal to 1 over F. So means that you can rewrite this one, means that L min for buck boost, same goes to other converter as well. So 1 minus d square r divided by 2f. So t is equal to 1 over f. So you just 1 minus d square times r divided by 2f. Because in converter we usually being given information about the frequency of our switching. So you just use the f here instead of you convert into t. And this is your ripple voltage. So you want to find out your duty cycle and your other parameters. So this is the basic equation that being extract from the syllabus that we have learned so far. Okay, we can go back to the question. Okay, first of all, from the formula just now, first of all, we try to find out what is the duty cycle of this scenario. So we have here the scenario whereby we have 4 volt and 8 volt input voltage to produce 12 volt of output. So in terms of formula just now was explained, was stated that V out equal to, this for boost converter, Vs divided by 1 minus D. So D is equal to 1 minus Vs over V out. Okay, and then we find out what is the duty cycle D for scenario whereby the input is 5 volt and another scenario whereby the input is at 8 volt. Okay, for R, V is equal to IR, so R is equal to V over I, given is the output current and also output voltage. So R is equal to V divided by I. So we have 12 divided by 1.5 ampere. So 8 ohm is our output resistor actually for this this system. So 5 volt 8 ohm, 8 volt 8 ohm. So the duty cycle for 5 volt scenario is calculated to be as 0.583, whilst when the input is at 8 volt, to stabilize our output at 12 volt, so the duty cycle need to be reduced down to 0.333 cycle ratio. So in terms of output average inductor current, average output, average current, so IL equal to Vs divided by 1 minus D square times R. So we solve for each scenario at D at 5 volt, at D at 8 volt. So at 5 volt, the average output inductor current is 3.594 ampere. Meanwhile for 8 volt, IL average is at 2.248 ampere. Okay. This happened at 2 scenario here. So then we find out what is the delta IL, which is delta IL is equal to 40% of average inductor current. So 40% of IL, 40% of average. So it's equal to 40 divided by 100 times 3.594. So we get for 5 volt scenario, 5 volt situation of 1.438 ampere. Meanwhile, when our input is at 8 volt, the ratio or the delta IL is 0.899 ampere. So next we need to find out the value of the inductor to maintain the scenario of 40% of this IL average. So we cannot use the IL, the minimum inductor value, because already stated the requirement here, and the IL naught should be at least this less than 40% of IL average. Okay, means that we have this formula inside the books, which is L, the value of our inductor, is equal to source voltage times duty cycle divided by delta L given here, delta IL times frequency. So for 5 volt input and 8 volt input, we should calculate separately. So the requirement of inductor value is different between these two levels. Later on we shall choose which one is better for our system or our converter, because only one inductor will be placed on the system or on the converter. So which value is most preferable? So L equal to Vs times D divided by delta IL F. So for 5 volt, 5 times duty cycle of 5.583 divided by the delta IL here, which is 1.438 times frequency of 500 kilohertz. So we shall get our output or our required inductance of 4.084. So you don't need to round up again, just put in the calculated value first. Okay, but for 8 volt input with the 0.333 duty cycle, so we get 5.927 micro Henry. So from next is that we try to find out the maximum inductor current and also minimum inductor current. So for maximum at 5 volt condition, IL is 3.594 plus delta IL divided by 2. So we shall get 4.313 ampere. Meanwhile, the minimum inductor current will be 2.875 ampere. And for 8 volt input, so the IL max is 2.98 ampere. IL min calculated to be 1.78 ampere. Okay, next is our capacitor. So C is equal to D over R times the output with voltage ripple times F. So for 5 volt input, our C is 0.583 divided by 8 ohm times 1.5% of the ripple times 500 kilohertz of switching frequency. So we get 9.67 microfarad of required capacitor. Meanwhile, for 8 volt incoming with the 0.33 duty cycle, so 5.5 microfarad of capacitor value. So which one actually, in terms of capacitor and inductor, that we should use to be furbished into our circuit now? So which one? So based on our what we have learned, the bigger the resistor value, the bigger the inductance value and the bigger the capacitor value, the better for our regulation. So the most proper is that in terms of their capacitor is 9.67. So this is the capacitor that we shall use. Meanwhile, in terms of inductance, so this is the value that we shall use. Okay, that's all for our discussion on question number 8. Okay, we proceed with question number 9 for the number 10 for the buck boost converter. For the boost converter. Buck boost we shall proceed after this.